Right, so good afternoon and welcome to TTL's Probing Plus for Siemens NX CAM webinar. Thank you very much for joining us. Very much appreciate your valuable time. What I'd like to present today is something which is very challenging to the marketplace, probing and putting it into the CAD/CAM world. So today we have three things that we're going to present. Myself, Simon Rogers, I have a background in metrology, machine tools and engineering software. And my colleague, Fran Wood, who has extensive experience in gas turbine component manufacture and also engineering software. The big question is why? Why have we bridged this gap? With my metrology background, I've realized very quickly coming into the engineering software world that making process control work and making it simple is really challenging. With diverse machine shops, with complex differences with machines which are very, very similar, to get all of these things managed in a PLM environment is critical. Ultimately, allowing engineers to deploy part setup strategies, in-process updates, inspection and reporting, and to make them fully associative to the CAD model, the master model approach, is really challenging. And this is something that we feel we have approached and tackled really successfully. So today's presentation is going to show you how it's done and how you can do this too. As I say, it's going to be made up in three sections. Firstly, we're going to show you a video, a bit of an introduction to TTL and Probing Plus, why, just to recap there. Secondly, and this is the main approach for us, is to show you how it works, the technical detail. And I believe there are two examples of different deployments, and we'll show you how those actually work in the NX world. And then finally, there's going to be a question and answer session, which we would like you to all take part in if possible. Within the webinar window, there is a question and answer button, and you can submit your questions there. They are moderated, of course, allowing us to take a selection of those, and we will try and do our best to answer them in the time available. Outside of that, we will, of course, take direct approach answers for something deeply technical to your own application, and can answer those on a one-to-one basis. So on to the video.
So TTL have been selected as the UK smart partner for NX CAM, which means that we're the only business that are able to support NX CAM fully in the UK. Siemens chose TTL as a smart partner because of our technical expertise, the fact that we have machine tools and also measurement capability, and understand exactly what manufacturers need. The power of Siemens NX CAM is harnessed by post-processors. TTL have specialised in producing industry-leading capability in that area by adding different functionalities such as Probing Plus, which gives you the ability to bring measurement technology into your CAD/CAM environment. The way that we've gone about this is to design and develop a product called Probing Plus. It's been a configurable backbone which has allowed us to upgrade host processors and give the template file that sits within the various versions of NX the power and flexibility to meet the customer's need. We find that some customers have a very deep technical requirement that requires lots of configuration, lots of customization. But with many other customers, we find that there's a very simple requirement where pre-configured menus and minimal choice is definitely the right way to go.
The Probing Plus add-on for Siemens NX enables further control of the manufacturing process from within the CAM environment. By allowing the offline programmer to integrate probing cycles and validation of the machine part seamlessly during the machining process, the programmer can add probing checks in line with machining operations to ensure the final cut is accurate and to specification. Key benefits are greatly reduced scrap rate, more consistency to finished components, and minimal manual input and chance for error. If for any reason the part has been set up on the machine incorrectly, the cut-measure-cut nature of Probing Plus can prevent pointless machining of a component that may already be scrapped by measuring features and verifying whether they are in tolerance prior to finished machining.
Right then, so hopefully that gives a very quick overview. Apologies, we're having to transition from slide to slide or video content to NX. I'd like to introduce Fran Wood now, who's going to show the two examples of Probing Plus deployed with some complex application overview. So over to you, Fran.
Thank you, Simon, and good afternoon, everyone. My name is Fran Wood, Simon said. I'm a CAD/CAM applications engineer. Okay, so this demonstration will focus on the Probing Plus integration of Siemens numeric probing cycles into a NX CAM session. In machining applications, probing is typically used for three things: to set a work offset, to adjust a tool offset, or for general part measurement and inspection. We'll take a look at how all of these can be applied in NX with Probing Plus. So, in this CAM session, we have a prismatic part loaded onto a 5-axis milling machine, and we have a number of machining toolpaths already created. Let's look at how we can use Probing Plus to create probing operations and add process control to the program. First, let's set a work offset. I have a machine coordinate system set in this bottom corner, or rather top corner of the component, and this is set as my G54 work offset. I'm going to use two Probing Plus routines to probe this corner point and update the work offset in X, Y, and Z. So, Probing Plus operations are created in a similar method to other CAM operations. I select Create Operation, and then I select the appropriate Probing Plus version. This particular template supports machine resident numeric probing cycles up to version 4.8. The Operation Subtype menu now displays a range of probing operations. These operations are complete probing routines that have been pre-configured to allow the programmer to create probing operations quickly and easily. Hovering the cursor over each probing operation displays a larger image that gives more information about the probing cycle that is implemented in each probing routine. The probing cycles and routines that are available in this numeric software version are edge distance set edge, edge distance align edge. We have cycles for measuring grooves, for measuring ribs, for measuring right angled corners, for measuring corners that are not right angles, for rectangular pockets, holes, the inner circle segment of holes, rectangular spigots, circular spigots, the outer circle segment of spigots, and 3D align plane operations. First, I'm going to use the edge distance set edge routine to set a Z work offset on the top of a component. So to do this, I select the edge distance set edge routine, and then I set the standard location settings. Here, I'm going to select a probe that's been previously exported to the library. And I'm going to give the operation a suitable name: probe edge distance set edge set G54 Z0. The sub-operation dialog now displays the 4 sub-operations that make up this probing routine. First, there's a rotary point vector move. This is used as a rapid move to initially position the probe. It's also used for orientating the machine for 3+2 probing operations. Next, there's a linear move to point, which is used to position a probe prior to the cycle call. We then have the edge distance set edge sub-operation, which is where we pick part geometry to measure and select any of the cycle options. Finally, we have a departure move to bring the probe clear from the component prior to any other machine rapids. More probing movements or cycles can be added or taken away from the probing operation, but these are the 4 typical sub-operations that are used in a probing routine. As a programmer, I just need to edit each sub-operation to suit the probing operation. So, moving down the list, starting at the top, I edit the rotary point vector move first. In the move definition, I can select an endpoint to rapid to. I can also select the vector of the stylus. For this example, I'm going to leave the endpoint where it is, and I'm going to select the ZC plus for the stylus vector. I want to probe the top face of this component and somewhere near this corner position. So I'll now edit the linear move to point to position a probe adjacent to the surface. So to do so, I'm going to use the point constructor and specify a point. And I'm going to choose this corner point and add a rectangular offset of 10 millimeters in X, 10 in Y, and 10 in Z. So here we can see the rapid move for a start. We can see where the probe is going to end up, which is just inland of this corner point in a suitable position. So now that the probe's in a suitable position, I can now edit the edge distance set edge sub-operation. And I want to update the work offset. So in the operation type section, I choose work offset. I can expand the work offset options. I want to set G54, and that equates to work offset number 1. And I also want to update the course field, so I'll leave it set as course. Now I move down to the geometry section, and I need to specify a surface point. That will input our Z value for the cycle. I'm going to choose this corner point. I could choose any point on this Z plane, as everything's level with Z0, but I'll choose this corner point. Finally, I need to select a probing direction, which in this case will be down the ZM, minus ZM. So that's everything selected in this sub-operation. Finally, the linear move away has been automatically pre-configured to rapid away 150 mm up the tool axis, which I'm happy with. That completes this operation. So I can now post-process the operation and we can have a look at the NC code. So this is the post-process code. Within the code, we can see the rapid move into position. We can see our linear feed move. And here we can see the cycle 978 cycle. This is the probing cycle call, which has been output with all the correct parameters that have been set from the geometry that was picked and the cycle options that were selected in the edge distance set edge dialog. Finally, we can see the rapid move away. Now we can actually simulate the machine and we can actually see the probing movement. So once again, we can see the NC code. I'm just going to put a breakpoint in at the start of the cycle, just so we can then pause and play from this point. So for now, press play. So we can see the probing picked up. We've rapided to our rapid position. This is our linear feed move into position. If I just zoom in a little, we press play again. We can see it probe at the top of the component where we wanted to probe it. With the toolpath trace, we can just have a look, make sure we're happy with that, which I am. Okay, so we've now set our Z. I also want to set the X and the Y. So to do so, I'm going to use another Probing Plus operation. So once again, into create operation. This time, I'm going to use the corner right angled corner routine. Once again, give this a suitable name, probe corner, right angle corner, set G54, X0, Y0. This time in the routine, rather than seeing the set edge distance set edge sub operation, we can see the corner right angle corner operation. So once again, going down from the top to the bottom, I can adjust the rotary point vector move options. This time I want to wrap it somewhere above this corner. So to do so, I'm going to go to point constructor again, select this endpoint, put a rectangular offset in, this time -10 in X, -10 in Y, 50 millimeters up in Z. I now need to move down in front of his corner position at suitable Z height to measure the corner. So I'll go into the linear move to point, once again into the point constructor, select the endpoint, this time with a rectangular offset of -10 in X, -10 in Y, this time -10 down in Z. So this is where we're going to wrap it to and move down to a suitable position to probe this corner. So once again, we go into the corner right angle corner sub operation. And once again, I want to update the work offset, so I choose work offset. I'm updating G54, which is our number 1, and the adjust type is coarse. So I'll then go to the geometry section. This type of corner is an external corner or outside corner, so we have this set as outside, and the corner position is bottom left. I now just need to add some values into these 3 fields to probe along in the X-axis and in the Y. So we'll go for 20, 30, and 20. But once again, that's everything set for this cycle. And we have a rapid move away at the end, which once again is 150 millimeters, which I'm happy with. Let me just check that I selected the corner point in this operation. And we can now simulate this. So once again, we can see our NC code. This time we've got the corner right angle corner, cycle 961 being called. So let's play this. So we've rapid to position, move down the tool axes. If we press play, we should see our 3 probing moves. Looks like I've not got something set correct in that cycle, so we can easily go back in and adjust this. So as we can see, if we ran that on machine, that wouldn't be correct. And as I can see, I've added the wrong value into the starting angle, which is trying to move the probe in an angular position. So I change this back to 0, 20, 30, and 20. Back in simulation. As you can see, we've now successfully probed this corner. Luckily, I've managed to spot this before getting down to machine and trying to run that on a machine. If I wanted to probe a little bit further up this edge, we can change one of these values. Let's have 100 mil up in the X. We instantly see the change this has made. So now I can see probing much further up in the X. And up in the Y. Okay, so I've now probed and correctly set the G54 work offset in X, Y and Z. Another application for probing is to adjust a tool offset. I've got 3 machining operations here, one to rough this pocket out, one to semi-finish the pocket, leaving 1/4 mil of stock on, and then a final finishing operation to machine the pocket to nominal size. The semi-finish and finish operations are being machined with the same tool. After semi-finishing the pocket, I'm going to probe the component to check the size and use the result to update the tool offset ready for the finish cut. After the finish cut, we can then probe the pocket and check the finish size. This is known as a cut measure strategy. So to probe this pocket, I'm going to go to create operation. This time I'm going to choose the edge distance groove routine. This time it's going to sit within the pocket group, and we'll give this a name. Probe edge distance groove semi-finish. Okay, once again from the top down, got a rotary point vector move for a start to wrap it to this position. For this cycle, I'm happy with that. So linear move to point. I now need to position the probe somewhere in the center of this pocket. So to do so, I'm going to select a point that's between 2 points on this pocket. And I'm going to add a rectangular offset -10 mil in Z. And this will position the probe in a suitable position in the center of a pocket and at a good measurement height. So once again, we go into the actual probing cycle sub-operation. This time I want to update a tool offset. So I select tool offset. I'm going to go to the tool offset group and enter the tool name, which in this case is NMIL16. And the edge number I want to update is edge number 1. So we go down to the geometry group again, and I need to select a point on the groove. When selecting this point on the groove, I'm actually selecting the nominal finished part size. As I know I've got 1/4 mil of stock left on this operation, I can move down to a stock group and add 0.25 into this dialog, and this will output the correct pocket size within the stock applied in the cycle call. I just need to select the starting angle. This is the direction the probe is going to move in for its first move, and I want to probe in this direction first in the Y+. So I'll pick the normal face, the normal to this face. Okay. Once again, we've got a linear move away at the end. So we can now move this to the correct position in the program order, which is between the semi-finish and the finish. And we can just have a look at this to make sure we're happy with it. So if we go to simulate machine, so you can see our rapid move into position, and successfully probing the part where we want to. After finishing the pocket, I want to check the pocket for final size. Rather than create a brand new operation from scratch, I can simply copy and paste the previous operation and change a couple of parameters. So I'll copy this operation, paste it after the finishing operation. Let's just change the name. Probe edge distance groove finish. If I go into the cycle now, into the sub operation. So we change this now from a tool offset cycle to a measurement only. And there's no stock now because we're machining to the nominal part size, so it changes to 0, and click OK. So let's generate this group, so everything's up to date. And I can now simulate the whole program group and simulate the probing toolpaths mixed in with the machining operations. So here we can see the pocket being roughed out. Semi-finished with another tool. Being probed, which will then update the tool offset. Pockets then finished nominal size with the updated tool offset. Then finally probed for finished size at the end. This has enabled me to digitally view the entire machining program and make any required changes within the CAM session. This can all be done prior to running any NC code on the physical machine, thus saving potential downtime on prove out. Once I've measured the finished size, I can display the measurement, add a tolerance check, or perform any recutting using standard logic statements that can be outcut with the NC code. Probing Plus can also be used for 3+2 operations to probe features with the rotary axis repositioned. Here's an example in this program group of a cut measure program with the rotary axes repositioned. If I simulate this group, here you can see this counterboard being roughed out. Semi-finished, probed with a tool offset operation to update the tool ready for finish cut. Finished nominal size, and then measured at the end. This completes the Probing Plus control demonstration for this part file. I'm now going to switch to another NX session. Okay, so we've just seen the support and the use of the machine resident numeric cycles of Probing Plus. The Probing Plus also supports the use of third-party probing software such as Renshaw Inspection Plus. Here I have another NX installer machine that's been set up to support the appropriate version of Renshaw Inspection Plus. Different machines and controllers require specific Renshaw software packages, and so each of our Probing Plus software versions are tailored to support the differences between the cycles. This CAM setup has got the same part, but it's set up on a different 5-axis machine. This time, if I go to create operation, I can see the version of Probing Plus with the Renshaw cycles, which is compatible with this machine. Here we see a familiar set of icons, but if I hover over these, instead of the numeric cycles, we now see information about the Renshaw Inspection Plus cycles, like this one, XYZ single surface measurement, and we can see the Renshaw macro below it. Just going across just to show a few more. angled surface, once again with the correct Renishaw macro below it, web and pocket, bore and boss, corner, fourth axis, etc., etc. If I post-process one of these operations, we can see the difference in the NC code. So here's the pocket measurement cycle. Here we can see the R variable being set prior to the cycle call. And this is the pocket measurement Renishaw cycle itself, the L9812. The Renishaw cycles also have inbuilt tolerance and probe control options available in the cycle. These can easily be applied to the cycle by adjusting the options in the Probing Plus dialog. For example, if I go back into this operation, back into the sub operation, here we can see some groups. So this is a tolerance group and a probe control group, where we can have various tolerances and control the probe in different ways. So just as an example, let's add a nominal tolerance of 0.1 and an experience value location of, say, 502. Let's now just post-process it again. Here you can see this is the same cycle call, but we've now got our 0.1 nominal tolerance being added and our experience value location prior to the cycle call. We can also simulate Renishaw cycles. This is a little inspection routine, which is just going to measure these three features. So once again, if we go to simulate machine, let's just expand this down so we can see the NC code. Here we can see the NC code being post-processed. See the probe moving into this first pocket, the probe getting Y. Moving across to this bore, doing a full point measure. Finally, we're going to move across to the other pocket. We'll measure this in X. I'm now going to move back to the presentation. As we've just seen, Probing Plus supports Renishaw Inspection Plus cycles. Probing Plus also supports other third-party probing software such as Bloom, Marpos, M&H, and MSP NC Perfect Part. Additionally, along with the cinumeric cycles I demonstrated earlier, Probing Plus also supports other machine resident probing cycles such as Heidenhain. Finally, in terms of supported NX versions, Probing Plus can be installed from NX 11 and all the way up to the latest constant release version. That completes the live demo for today. Thank you for watching,